Okay, so we have our next question right here. It basically says that a student investigated small ball bearing falling through a liquid to determine the viscosity of the liquid. State the conditions for the Stokes law to apply in this investigation. So we have only three conditions right here. So the first condition is it should be small, spherical, right? And the second thing it should be at low speed, and the third condition should be laminar. Laminar. Okay. So these are the three book definitions, or you can say the conditions, right? So you just need to apply them here in this question as well. This is already mentioned, the small spherical, the small ball, and you just need to say the other stuff, which is that it should be at low speed and it should be laminar. That's it. So this is your final answer. Okay, so we have the next part right here. It says complete the free body force diagram for ball bearing when it's falling at the terminal velocity. It's very simple. So you have a ball inside the water. The force that will be acting is one of its, as shown, a drag force, and the other one will be every single time will be up thrust. Okay, and the other thing is the weight. These three forces will be only acting in it, right? So you will get marks, 2 marks for up thrust and weight, but you have to draw it properly, right? Because terminal velocity means velocity is zero, so they are both equal on both sides, right? Up and down. So for example, if you draw up thrust like this much, so you need to add these both lines up and make the weight according to it, right? So because this actually matters, don't make the up thrust too big and the weight too small, because then it doesn't remain at the terminal velocity, right? So you need to have this at basically both sides up and down equal. So this is your final answer. Okay, so we have the next part right here. It says the student thought that the liquid she used might be glycerol, and she made measurements to determine the terminal velocity of the ball bearing. The terminal velocity of the ball bearing is there. The liquid, she discussed whether this liquid is this or not. Density, radius, weight, and viscosity is given, right? So you can either find terminal velocity at the end, or you can go for the viscosity. Either of it is your choice. You just need to prove one of these values whether they match or not. If they match, it is the liquid she thought she used. If not, then you can say no, she used some other liquid. So if you remember the free body diagram, it was weight down and up thrust plus drag force both up, right? So you say up thrust plus drag is equals to weight. You can find drag from F is equals to 6 pi r viscosity V, and for up thrust we can use the formula of same for the weight mg, but remember you're not finding the actual basically weight of the ball bearing. You need is basically for the liquid, not for the ball, right? Remember that, because if it was for the ball, then it comes in the weight category, not in the up thrust category, right? So this up thrust, right? Now up thrust is equals to mg. Now where we will find this mass if we can't use the ball bearings mass, right? So you can find it through this basically right here. You have been given density and you have been given this radius as well. So if you remember the density's formula, you know that density is equals to mass by volume. You get the mass from here. Okay, so now you need the volume. Where I will get the volume? You can use the volume of this sphere, right? So the volume sphere is 4 by 3 by r cube. Okay, so always you have to remember this formula, because this is the only formula used while you are calculating some values with viscosities and drag force and blah blah blah. You use volume as this, right? So which is the sphere volume sphere. So now you have density, you will find the volume from here. So let's find volume first. Okay, so volume is equals to 4 by 3 pi r is what? 2.30, but remember it's millimeters, so you need to convert it into meters, right? So it divided by 1,000. So now, and make it cube, and now you will get your answer as 5.1 times 10 to the power minus 8 meter cube. I don't have the calculator right now, so I have already written the answer for the volume. If you have the calculator, use the calculated version answer, right? Not mine answer, because like it could cause some errors or some, like, change in values for your final result, right? It might not be the same as the final result for the mark scheme, right? So make sure that you use the values for the from the calculator, not the rounded off values, right? I'm using the rounded off values for now, but you shouldn't use it. It's not like much recommended. So now what we will do is we will find the mass. So mass is density times volume, right? So density is what? 1.26 times 10 raised to power 3 times volume, which is 4 by 3, not 4 by 3, my bad. It's now 5.1, blah, blah, blah. You have something else value, right? Times 10 raised to power minus 8, right? So now if you calculate this, you will get 6.43 times 10 raised to power minus 5 kg, and then you can use it in here. The mass you will get up thrust is equals to what? Up thrust is equals to 6.43. This is again rounded off value. Don't use rounded off values, right? 6.43 times 10 to the power minus 5 times 9.81 gravity's value, and then you will get 6.31 times 10 to the power minus 4 newtons. Now the upthrust is out of our way. We got upthrust, we have weight. Now it's only left with the drag force, right? And we need from drag force the V part, or you can find the viscosity part, right? So we only need them for comparison, right? Sorry, this is R. My bad, this is viscosity, right? So you can use either two of those, right? Now, so if you use the formula for drag force, which is, and make the upthrust come on the right side, right? So you can only focus on the drag force right now. So your drag force formula is 6 pi r viscosity V is equals to weight is, what is the weight? Weight value is 4 times 10 to the power minus 3 minus the upthrust, which is 6.31 times 10 to the power minus 4, right? Now you can put the values for the radius as well. So it is 6 pi, and radius should be in meters. So it's, if you divide it by 1,000, you just say it's 0.0023, right? And you can use either, you can find viscosity or terminal velocity. Right now I can find viscosity for you. So you need to find viscosity, and your terminal velocity as she given was 0.0824, 0.0824, and yeah, this 4 times 10 to the power minus 3 minus 6.3 times 10 to the power minus 4. You subtract them, and then you basically divide all of this value with this. So it's 4 times 10 to the power minus 3 minus 6.31 times 10 to the power minus 4 divided by the whole of this value, 6 pi, 0.0023 and 0.084824. If you calculate this value, the answer I got rounded off, right, was 0.94, sorry, let me raise it, 3 pascals. Remember, the viscosity unit is pascals, right? Pascals per second, my bad. Pascal second, sorry, not pascal per second, pascal seconds, okay? PS. So now if you compare it with this viscosity, you will know that this viscosity is less than this viscosity, right? So you can say that 0.934 is less than 0.943, right? So no, it might not be the same liquid, but sometimes you can either say yes or no. It depends on you what statement you want to give.